Hi, we have earlier discussed continuity and we are going to continue by discussing limit. Limit. On this first graph, we can see the point 3 on the axis which correspond to 5. So this function at f of 3 equal to, that is correspond to 5. If we take the limit as x tends to 3 from the left hand side of f of x, from this left hand side, so this is the left hand side, you see that it approaches 5. And if we also take the limit of f of x as x approaches 3 from the right hand side, this is the right hand, from the right hand if it approaches 3, we can see that it also gives us 5. That means we say the limit of this function, the limit as x approaches 3 of f of x is equal to 5. On the next function, we can see that the function at 4, when x is 4, we see that this function is undefined at that point. It's undefined. Now, if we look at the limit of f of x as x approaches 4 from the left hand side, this is, we can see that it approaches the value there, 7. And when we also check the limit as x approaches 4 from the right hand side, sorry, let me write from the right hand side, this is a positive value to indicate from the right hand side of f of x. From the right hand side, we can see that the value also tends to approaches 7. So we can conclude that the limit as x approaches 4 of f of x is 7. As long as the left hand limit is equal to the right hand limit, then the limit does exist. The next graph below it, we can see that the f of the value 5 is, this top part is a shaded part, while the one below has a hole, so it is 10. So because the top part there, that's f of 5 is 10. If we check the limit as x approaches 5 from the left hand side of f of x, that means on this part of the graph we can see that it is approaching 9, the value 9. And if we cross check the limit of f of x as x approaches 5 from the right hand side, the limit is 10. You can see from this graph, if it goes up, there is 10. So therefore, these two limits does not correspond. So the limit as x approaches 5 of f of x, we say it does not exist. On the next graph, f of 7, we can see the point. At this graph here, there is a loop, so it is not the point at the top where there is no loop. We can see that f of 7 is 6. And the limit of, let's give this a value here. Let's say that would be 5. So the limit of f of x as x approaches 7 from the left hand side equal to 5. And if we look at the limit of f of x as x approaches 7 from the right hand side. From the right hand side, you can see there, from the right hand side, there it is also 5. So therefore, we can conclude that the limit of f of x as x tends to 7 is 5. Here we can see a straight line that from the left hand side and from the right hand side, that they are not meeting at all. So f of 4, we say the value does not exist. The limit as x approaches 4 from the left hand side of f of x, you can see that the value is going higher and higher. So it's moving towards always positive infinity. And the limit as x approaches 4 from the right hand side of f of x is also positive infinity. Therefore, the limit as x approaches 4 of f of x, in some textbook or some authors, it is said to be infinity, while some choose to say it does not exist. On the last graph below, we can see that it also has a vertical asymptote. So f of 6, we also say the value does not exist. Because from the left hand side, we can see the graph pointing downward, and from the right hand side, the graph is moving upward. Therefore, the limit of f of x as x approaches 6 from the left hand side. We can see from the graph that is going downwards towards the negative infinity, and the limit from the right hand side as x approaches 6 of f of x, it is going upwards, so that is positive infinity. So on this graph we say the limit of f of x as x approaches 6, we say it does not exist.